Okay, we're about to do one of the most important parts both for this course and for calculus. Determine the slope of the line of the tangent. So let's be careful here. Suppose you have some sort of graph on a Cartesian, and let's just suppose it's a strange one. We'll do it like this, maybe something like this, and something like this. And they ask you to find the slope of, or the formula of the tangent line. Let's suppose that they're talking about a spot right here. And let's suppose you draw a tangent line in green, like that. And tangent lines have to go 90 degrees roughly. And that's just an estimate. When they ask for the formula of this tangent line, they're asking for a line formula because all tangent lines are straight lines. So they're looking for something in the format of a line. To determine that format, we would need two things. We would need to know B, and we need to know M. Now, fortunately, M is determined when you find the actual instantaneous rate of change, because that's actually the slope of that line. So when you find the instantaneous rate of change, you find that one. You find it. But to determine B is very difficult. Fortunately, you have an X and a Y value in the very point that you are examining in the first place. This spot here, if they ask you to find this point, let's say that point is minus 2 comma 11, minus 2 comma 11, you now have an X and Y value. Let's suppose the last one was, let's put it like this, minus 2 comma 11. And you're looking for the instantaneous rate of change. And let's say you find it, you discover that it's minus 2. The only thing you're missing now is B, but fortunately they gave us a point on the graph. They gave us the point, well, let's say minus 3 here, so not to be confused. They gave us the point minus 2 and minus 11. Now all I have to do is solve for B. Once you solve for B, you go back and write the generic formula. And now we have the formula for the line of the tangent. You will see this being asked over and over again in this course and in calculus. So learn it. It's a valuable thing. To solve any line formula, you need either M and B, or M, X, and Y, or B, X, and Y. And then you can solve it. Fortunately, in all these questions, you usually get M and 1 point, 1 X and Y. So back to the questions. Here we go. In 6, they want us to determine the slope of the line for each of these. Now, again, I'm going to cheat a little bit in determining the instantaneous rate of change, because it would take me a long time to do the math of it. But essentially, if you were to look at this, I don't know what the second part they're getting at. Then determine the value of X at which there is no tangent line. Not sure what they're getting at there. But if you were to determine this, you would take 2 points. You would first find the point where 2 exists. You plug it in. You get minus 10 divided by 7. So you get minus 10 over 7. And then you have to determine this. What's f of a plus h minus f of a over an arbitrary amount of h. So if I'm going to use this for h, then I do that here. And we've just determined what f of 2 is. And here we have to do f of 2 plus this. F of 2 is minus 10 over 7. When you get a minus minus, it becomes plus. So plus 10 over 7. I'm not going to convert it to decimals. But we have to find what is f of 2 plus 0.01. In this case, you can punch it in your calculator. Let's do it. So 2.0, and always use the same h that you have at the bottom, right? You can't mix your h's up. So you're doing it with that. It's multiplying negative 5. And then it's dividing it by 2 times 2. Oh, hang on. Let's go back. 2.0 0.01, I'm going to put that in memory, times -5 equals, and then it's being divided by, open brackets, 2 times my memory plus 3, close brackets, equals. And there we get. And now remember, it should be quite close to the other one. And in this case, it is. And since the other one we need to convert it to, we're going to take this and we're going to add 10 divided by 7 and click equals. And we get this very small number. Then we have to divide it by 0.001 and we get this, minus 0.3. Now, just to make sure, I'm going to pull up Desmos because there's a lot of calculation errors you can make when doing these. So we're going to pull up some Desmos. We're going to put in the graph f of x is equal to minus 5x divided by 2x plus 3. We're going to just have it do it entirely. We're going to define h. We're going to define x2 plus h minus f of 2, all divided by h. And we get the same answer, so that means our calculation was correct. So that means this is our m for our slope. This is our instantaneous rate of change for that particular point when 2. Which means if I want to find the slope, let's look at the drawing. And we can see that the point in question is 2 comma f of 2, right there. And they want to find a slope of the graph, the line formula for the slope of the tangent right there. Well, we have the slope. And we have a point on there. We have point minus 10 over 7. Times 2. And then we just have to add it, minus 10 over 7. Plus all of this times 2 is going to be equal to b. So let's pull up our calculator again. We have this in there already. We just have to multiply it by 2. And we have to make it positive. Then we have to add it, or subtract rather, minus 10 divided by 7. And click equals. And that means our b is this. Which means we can rewrite our line formula as this. And the trick here will be to take this and put it into Desmos and see if we get the line tangent. And of course, there's a chance we might not. But let's take a copy and bring up our Desmos and see if we get the line of tangent. And sure enough, we do. Let's color it a different color. There we go. That is indeed the line of tangent for that point, which makes sense because you can see that point is kind of going around the bend and flattening out, which means the blue line won't be quite at 45-degree angle. And so there we go. We've learned how to do a fairly complicated line of tangent. Now the other ones I'm just going to let Desmos do it. So that was A. Now here's B. And I don't know what the second part of that question means. Find an x where the value of x, there is no tangent line. Oh, I guess it's a total vertical. So vertical lines don't have a formula. You cannot have an x value for a vertical line. But I don't know if anywhere in that graph there would be a vertical line. But let's go back to Desmos. We're going to put in this formula instead. Oh, I have negative. Well, it doesn't matter. It doesn't matter if I have negative or not. So I'm going to put in the correct formula here. This new formula is x minus 6 divided by x plus 5. We're going to keep the same h. And they're looking for when x is minus 7. So we're going to put minus 7 here. and minus 7 here. And we'll instantly get the slope. Now the fast way to do the tangent line, so this old one is no longer the slope, obviously. We're talking about that point, and we should just do this. And you know what you can also do? You can speed this up here. You can add a new line, and you can just assign your A. So in this case, our A is equal to minus 7. And you can just put A in here, and A down here. You do A, comma, f of A. And that will do it as well. So we're talking about that point there. And now you can see we have this slope here. I'm going to just make it full. We have this slope here. So if I was to write that into a formula like that, I have it like this. Well, all I have to do is put in my A values, which apparently was 6.5, and my X values, which apparently is minus 7, and solve. So all I have to do is get rid of that and say when just do plus 7 times this, and it should tell me what it is. So that's my B. Now I just rewrite it with the slope plus my B. And there we go. We got a nice little slope line. So what did I do? Let's run through it. First I used an H, then I set my X value to minus 7, then I solved my Y value there for minus 7 plus H minus F of minus 7, and then I divided by H. Then I plotted the point A comma F of A, which is minus 7 comma 6.5, shown right here. Then I calculated my B by writing the let's keep that in. Now let's go through it again, but this time with the actual values. So here I did minus 7 plus H. And here I just did minus 7. Now if you want to do it bit by bit, F of minus 7 plus H is this. So you could just take this. You have to subtract the 6.5, which is F of minus 7, and you have to divide it by our H. There you get the same slope. That's the same thing, y2 minus y1 over x2 minus f1. You can then plot that point. So the point that we're plotting is minus 7 comma 6.5. The same thing as A comma F of A. And then when I figure out my line formula, I'm using the slope I found above. Let's just use that. But I need to solve for B. So fortunately, I know a Y value is minus 7. And I know an X value. Oh, sorry, minus 6.4 or 6.5 rather. And I know an X value, minus 7. Minus 7 times 2.75. So it's minus, but now I'm going to add it to the other side. So I'm going to add it to 6.5, and this is my B. So then I just make the whole formula here. I'm just going to shorten this so it's easier to see. There's the instantaneous rate of change I found, and there's the B I found. And now I have a nice purple tangent line. That's what all these questions are asking you to do over and over again, and that's because practice makes perfect. Okay, so for this we have to find, let me walk through the steps of this so you can see what the steps are. Here are all the steps for solving this. So they give us X. So find the Y value for that X. The Y value is the same as F of minus 2. So to do that, you just plug it in. What's 2 times minus 2 squared? It's 2 times 4, which is 8. Minus 6 times minus 2, which is plus 12. What's 8 plus 12? 20. Now at the bottom, what's 3 times minus 2? Minus 6. What's minus 6 plus 5? Minus 1. What's 20 divided by minus 1? Minus 20. Which means we're talking about the point minus 2 comma, minus 20. Now we've got to find a point that's just to the right of this. We're going to add h. The point just to the right of that is minus 1.999, which means we have to find f of minus 1.999. And to do that, it's easier using calculator or Desmos. So we're going to take 1.999 negative. We're going to square it. We're going to multiply it by 2. We're going to subtract 6 times 1.999 negative. We're going to hit equals. And we're going to divide it by, open brackets, 3 times 1.999 negative plus 5, close brackets, equals. And this y should be very close to the other y. So it's equal to that. Nope, I didn't get the right thing. Oh, somehow well, we're going to let Desmos do it, because I had it and then I lost it. So up here, we're talking about 2x squared minus 6x over 3x plus 5. So we're going to skip the h, and we're just going to do it old school. They're talking about the point minus 2. Minus 2, as we've discovered, is minus 20. So we're talking about minus 2, comma, minus 20. And we're going to label it. And now we have to find the point just to the right of that. So that means they're talking about the point just to the right of it. And that's the point just to the right of it. Now, we're going to have to divide the point, take the point just to the right of it and subtract the point just to the left. So we're going to get this. All divided by my h. Which is that. So now we have the slope. Now we have to calculate b. Well, let's isolate b in this formula. B is going to be, if I subtract y's, b is going to be equal to y minus mx. Well, we just figured out m. M is minus 46.1404213. And we figured out y. Y is minus 20. And we figured out x. X in this case is minus 2. We got a b of that. So now we have the slope. And we have b. Let's go see if we got the right point. And we got to pull this up like that. Yep, there's the let's make the tangent line a different color. And there we go. This blue line represents the tangent line for that red line. We're going to zoom right in. Notice it's slightly off. Oh, that dot's up here. Let's just get rid of it. There we go. If you zoom in, you'll eventually see the difference between the tangent line and the graph, but you have to zoom way in when it's this tight. There it is. Go back to home. And there you go. You've done a tangent line. If we zoom out, you can see the tangent line separates from the actual line. Now, how would you do this? The formula they want you to do. Well, we know the a they're talking about is minus 2. And we know the h we want to use is this. So now if we just do it with their formula, the formula is f of a plus h minus f of a, all divided by h. Now we have the slope. Technically, this is the slope, right? So we can just put that right in there. We just need to figure out b. Well, b, as I said, is equal to this. But we just figured out the slope. So we figure out the slope is this. We figured out we can just skip what b is. We figured out y is f of a. And we figured out x is a. And I think that was the slope, wasn't it? So since this is b, we can put it right in for b. And there we go. Let's not forget to label the line, a comma f of a. And there we go. We get the same slope formula in a very complicated slope formula. Let's just explain what's going on there. This is the slope because we figured that out from the instantaneous rate of change up here. This is x. We figured out that b is equal to y minus mx. Well, this is m. We already figured that out. This is x, and this is y. So that means we can just replace b with all of that. Or if you want to make your life simple, it's just that. And if you want to make your life simple here, just that. Same thing, just goes to show that you can include the actual formulas in the line formula to figure it out. Oh, we got to get rid of this. There we go. So it's either way. This is obviously cleaner, but you can see you can have Desmos calculate everything for you. Because this is b. It's y, which in this case is minus 20, minus the slope you figured out, times a, which is the x value we're studying. And you can see they give it to you, same answer. All right, let's do the last one. It's got a 5. This is the last one. So we'll just put that into Desmos, and we're going to just let Desmos do all of it. This is 5, x minus 6. The a in question, or the x in question, is 4. We'll let Desmos handle the entire slope here. So that's the instantaneous slope right there. We're going to let Desmos figure out our, we'll do that too. We're going to let Desmos figure out our b. Our b is going to be equal to y, which we've discovered is minus 2.5, minus our slope times our x. And there we now have our b. Putting it all together, this is our slope from our instantaneous rate of change times x plus our b. And look at that. It drew a lovely tangent line through that point. A tangent line should only cross the line at one point. And since we figured out b based on that point, your tangent line will always be perfect. This is a very important skill set to learn, especially the shortcuts, especially what it all means. When they ask you specifically, they just wanted the slope of the line. Okay, so we went too far. But, however, finding the line formula is going to be coming up and is incredibly important. Okay, we'll do 7, 8, 9. Okay, and the rest of the questions are very similar in nature. And sometimes you can ask yourself various questions like, this is clearly, I believe, 3t squared. I'm going to just consult the book to make sure. Oh, no, it's just 3t. And yeah, that's just 3t. So ask yourself when it's 27 over 3t, 27t over 3t, what's the horizontal line it's going to be reaching? It's 27 divided 3, which is 9, which means on a graph, its maximum it's going to reach is at y is equal to 9. The other information you can look at is the bottom. When is 3t plus 1,000, 10,000 equal to 0? It's when 3t is equal to negative 10,000 and divided by 3. It's roughly negative 3,000, 3,000, 3,000, 30,000. So way over here is going to be a horizontal, vertical asymptote. So you probably have something more like that. And then on the right, it's something like that, or on the left. But really, they're only going to be concerned from time 0 onwards, because in time questions, we don't care what happened back in time. You know what I mean? But let's look at the specific question. This is water flowing into an unpolluted pond. Concentration of polluted sea in the pond at t minutes is modeled by this. So there's some pollutant coming in if the pond was unpolluted. And this is kilograms per cubic meter. Determine the rate of concentration is how fast it's changing after 1 hour and 1 week. So since t is supposed to be measured in minutes, and neither of these are minutes, we should convert them to minutes because the equation accounts for minutes. So 1 hour is equal to 60 minutes, and 1 week is equal to 7 days times 24 hours times 60 minutes. So if we do that very quickly, 7 times 24 hours times 60 minutes. And we determine that that's this many minutes. So really, these are the timelines you should be seeking for, which means we have to place them in the equation. If you do the first one and you just put 60 in wherever you see t, let's find the y. So it's 60. It's 27 times 60 divided by 10,000 plus 3 times 60, which is 180, close bracket, equals. So we can see this one's just barely, there's a barely this many kilograms per cubic meters. So this represents the coordinate 60, comma, that. Whereas 10,080 represents this. What's 10,080 times 27 on the top divided by, open brackets, 10,000 plus 3 times 10,080, 10,080, close bracket, equals 6.76. So you can see this one is, the second one is reaching a closer to 9 result. It represents this spot on the graph. Now, obviously, we have to take a point just to the right of 60 minutes, and the smaller the better when we're talking minutes, and to the right of 80, and the smaller the better. So we're going to use an h of 0.0001, 3 zeros, or 4 zeros even. But to make my life easier, let's pull up Desmos. And we're going to just put that equation in there, way up top. It will be divided by 10,000 plus 3t. And we're just going to use x instead, because sometimes I get confused with x. And obviously they're talking about the first point, 60, comma, f of 60. Boom. So they're talking about this point. Right there. Now, to get a better idea of scale, we should change the y-axis from like 0 to 9, and that'll help us out a bit. So you can see the rise, and you can even do it a little bit smaller. You can squish the x-axis a little bit, like 0 to 2. That'll give you a better idea. Oh, there, that's the y-axis. And this one, we can just make it from 0 to, or even right around 60, 55 to 65. Okay, well, let's stretch it out even worse. 0 to 1,000. There we go. That gives us a better idea of what's going on. And just to show you, I'm going to put the y is equal to 9 to show you that it's always going to be trying to reach 9, but not quite get there. And sure enough, there's the other side of the graph. So the left side actually doesn't matter for this graph. The graph only matters for when time is bigger or equal to 0. So that's the real graph that we're concerned with. And the point in question is right there on the way up. So now we're going to find a spot that's just to the right of it. And that's the point. Now we're not going to bother labeling it. But we are going to find what f of 60.1 is. It's that. So that means we're going to take that. And we're going to subtract the f of 60 point. And let's just find out what the f of 60 is, because it's not quite accurate up there. There we go. And we're going to divide that all by our point. Like that. I don't believe that's right. So what we're going to do is do the standard way. We're going to make our A is equal to 60. We're going to make our H equal this. And we're just going to let Desmos do it. Like this. And it is that. Okay, because this is, I guess because this is drawn a little bit weird. And so that's the rate of change. It's barely increasing at 60. Now let's do it for 10,080, was it? 10,080. And that's all you have to do is change the A. You can see that one's barely climbing. Much, much smaller than the original one. Here's the original one. Much larger number. So this one, in this case, is 1080, comma F. It's an 80 right over there. And it looks like it's climbing, but you got to remember I changed the scales of X so that we could see it. If you do a normal scale of X from 1, 0 to 2000, you can see that the actual climb is flatter than it would appear. And those are the two questions. That's all they wanted. So this one's changing much faster because it's going up the slope, and this one's changing much slower because it's reaching closer and closer to 9. So a demand function, number 8. Number 8, demand function. Demand is just when people want something. When people want something. So the demand is represented by a number over a quadratic, which means y is equal to 0 is going to be the horizontal asymptote. The X units are given in thousands of cupcakes, and the price per snack, cake P of X. So that's the price for each cake. So that's the price based on each cake. So the price clearly goes down as the cakes go up. Find the revenue function of the cake. So revenue is, that's interesting because price, when you sell something for a price, if I sell a cupcake for 5, my profit is going to be based on how many cupcakes I sell. That's going to be my profit. Or my revenue. Sorry, revenue. So that means if this is my price, right here, to figure out my revenue, I have to take my price, and I have to multiply it by how many cupcakes I sell, which in this case is thousands of cupcakes and X. That's revenue. Estimate the marginal revenue for X is equal to, what is the marginal revenue for X is equal to? So that means if I multiply this, it's really, I get 15X over that. So let's have a look at that in Desmos. I'm going to put the overall formula here. And remember, we'll multiply it by X now. And it's over 2x squared plus 11x plus 5. So we're talking about this. And they want to know 0.75 and 2. So again, we can see for this one, the graph is going down, down, so it's sort of really climbing in the beginning. So that's the most profit right there. You can sell 1,581 cupcakes, and that's your max profit in thousands of dollars. So $866. And they want to know for when A is 0.75, how quickly are we making revenue? And it would be this. F of A plus H minus F of A, all divided by H. So that means we're making $281 per cupcake at that point. And then if we look for 2,000 cupcakes, we're actually losing money. You can see 2,000 cupcakes is on the way down over here. It's heading down. So we're losing money per cupcake. We're losing $36 per cupcake as we hit 2,000. So your best price for cupcake would be right here. You should be selling 1,600 cupcakes and making $866 per cupcake. And there you go. Now, I'm not 100% sure that's the answer. Yes, it turns out that is the answer. There indeed is our revenue formula. We have to have X in there as guessed. And there are two results. We're losing money at 10,000 and we're gaining money at 0.75. So just to bring back the 0.75. We are indeed gaining 0.281, or as they do, they round it up to 0.3. It makes sense. Right there, they rounded up 0.3. So there you go. We were right on all counts. Looking at number 9. Small clothing company, the estimated cost function, so cost is how much you have to pay to produce something, is based on a parabola divided by x. And that means this is going to have a diagonal asymptote because the x degree up here is bigger than the x degree, where x is the number of t-shirts produced in thousands and c is the measurement of cost in dollars. Calculate the average cost of t-shirts at production level of 3,000 pairs. The average cost of a t-shirt. Calculate the average cost at a production level of 3,000 pairs. Now, since they tell us the number of t-shirts is produced in thousands, 3,000 would mean the x I put in there is actually 3. And the average cost, that's an interesting question because instantaneous rate is not average. But let's just assume they want instantaneous rate of change when t is 3. So if I put that in, I've got to put in the formula. And I get, just use f of x again, x squared minus 4x plus 20, all divided by x. And we're just going to change our a. We're going to assume our a is 3. And we're going to do a big old, what is f of a plus h minus f of a, all divided by h. So we get a negative result, which is not good. So cost, so if they're asking average cost of t-shirts at a production level of 3,000 pairs, let's try 3,000. Average cost, no, they're still saying that. So they're not looking for that. So they're looking, if they're talking about 3,000, they're looking from 0 to 3,000. So how to do that is this. We don't use h. So between 0 and 3,000, x2 is equal to 3,000, x1 is equal to 0, which means my average, or my x2 minus x1, is going to be equal to 3,000. To find the 2, we should find f of 0. It's undefined, so there is no 0. So we'd have to take 0.001. So we're going to take f of 3. We're going to take f of 0.0001. And we're going to divide it by 3,000. And this says we're losing that. How about if we divide it by 3? Since we're losing that, what if we use 3,000 here and 3,000 there? No, still not getting the right answer. So I wonder what they mean. Calculate the average cost of a t-shirt. Oh, I think they just want me to say what f of x is. Oh, stupid. So what if f of 3? There you go. Yeah, so you got to convert the 3,000 to 3, and there, that's the average cost. And then estimate the rate of change at which the average cost is changing, and that's what I did before. So the average change, where a is equal to 3, h is equal 0.001, f of a plus h minus f of a divided by h. So you get negative 1.222, and they're saying negative 2. I don't know how they got that. Estimate the rate at which the average cost is changing at 3,000 t-shirts. Yeah, that should be it. I don't think they got their average rate of change correct. Yeah, I don't think this is right. One of the few times I can say that with quite a bit of certainty. Okay, moving on. Suppose the number of houses in a new subdivision is given in t for months of data is given by this model. Notice that they have a t cubed up top and a t up top, which means this model will reach a maximum of 100 because it's 100 t cubed divided by 1 t cubed. So the maximum it's going to reach is 100. You'll never reach it. And they only want the range between 0 and 12 houses. Or sorry, 0 and 12 months for the first year. Calculate the average rate of change. So that's n of 12 minus n of 0. By the way, n of 0 is 0. So only n of 12 divided by 12. Oh, 6 months. So n of 6 minus 0 over 6. Calculate the instantaneous rate of change in the number of those at the end of the first year. So that's n of 12. Graph the function using a graphing calculator. Well, let's start backwards. It will always help us to see it. So here's our formula. And we'll just use x instead of t. And just to show you, put the h in there. Do that later. Yeah, we'll get rid of all. Oh, I did t, didn't I? Yeah. And just to show you, f of 0 will be 0. And f of 6 will be this. So to calculate the average rate of change between 6 and 0, it would be f of 6 minus f of 0, which is 0, divided by 6. So that would be, and this is where n is the number of houses. So you make an average, they're making an average of 11.39 houses per month between 0 and 6. That's the average. And then calculate the instantaneous range at the end of the year. So the end of the year is F12, which means we'd have to find one just to the right of it. So let's just call A equal 12. And we're going to call H 0.0001. And we're going to do A of F plus H minus F of A, all divided by H. And that means you're making about 1.29 houses or 1.3 houses per month at that point. Now to show you the other things that I was talking about, let's make y is equal to 100. And we're going to put it on a scale of y from 0 to 100. And from x to 0 to 12. And you can see it looks like that. And if you want to get an idea of what period they're looking for, they're talking about only about 0 to x to 12. So they're only talking about that portion of the graph. So you can see right in the beginning, they're building a lot of houses. That's their peak house development right there. Then it slows down. But at 12, they're averaging. Interesting. Why is that undefined? Did I include the 12? No, should be included. F of, oh, I know, because plus H just puts it above 12. So I have to just push this to, let's say, 13. There we go. You can see they're building right at the 12. They're building about 1.3 houses per month is the instantaneous. And then the average was higher. Let's see if we got that right. I think I kept the, no, I didn't. Let me just keep a copy of this. Let's see if I still got, no. Oh yeah. So they're saying an average is 68. And they're saying the instantaneous 94. So I did something wrong there. So make sure my formula matches the book. $100 plus t cubed. I might have got it wrong. Yeah. Oh, it's not 100. Yeah, it's 100x cubed. So we'll try that again. So the average will be from f of 6 minus 0, or f of 0, all divided by 6. Yeah, I got that. I don't know why they got this. They got 68.46. And 94.54. Don't think so. Just gonna make sure that formula I put in is correct. That's cubed and that's cubed. Yeah, it should be 6 minus 0 should be x2 minus x1. Should be 6. Yeah, it's impossible to have that average if at F6 they've only built 68 houses. There's no way you can have that average. So either again they did something wrong or I did something wrong, but I don't think so. So moving on. Number 11. X minus, given this function, where would the average rate of change and the instantaneous rate of change be the same? That's interesting. Get rid of that little clean in. Yeah, that's a good question. Perhaps find the. Oh, I think this is a graphing question. So let's just try using graphing. Ooh. Yeah, where would the average rate of change be the same as the instantaneous rate of change? Okay. We don't know what A is. I'm just going to call A is equal to I'm going to make an H. We're going to find where f, we're going to call it a minus a plus h minus f of a divided by h. We're going to add a slider. And we're going to ask ourselves, when is that going to match an f of a minus an f of 0 divided by a minus 0. And we're going to see when these two, when this number matches this number. Let's call this g of x. Let's call this h of x. Okay, j of x. There we go. Let's ask ourselves, when does j of x equal g of x? And they're saying right there. Now I'm going to turn off the other graphs. And it's telling you right there. So we're going to zoom in. And they're saying when y is negative 0.071. There's a whole bunch of points along there. Let's turn this graph back on. Okay, when does f of x equal, let's find that again, negative 0.71. You're saying it's down in this thing. Don't know how it popped up. We're going to do that. Okay, we'll just see where the graph hits that line. Right there. So they're saying at 2.2. So we'll check that out. Okay, let's try 2.2 then. So we're going to find the instantaneous rate of change at 2.2. That's that. And then we're going to find the average rate of change for 2.2. No, they don't match. Interesting. Let's try this all again. We're going to call this A. We're going to call this A. And put smaller steps in there. And another 0.2. Somewhere around there. There you go. There's close. Take it off. It's close to that. So 0.55. Closer. Very close. Very close. Almost identical. So when A is 0.02. Yeah, somewhere in that zone. So A when A is 0.012. So let's figure that out. Yeah, the average rate of change and the average rate of change and the instantaneous rate of change are roughly when A is equal to 0.02. The only way you could figure that out though is with graphing technology. There's really no other way to figure that out.